Today we'll talk about inter-VLAN routing, and we'll consider legacy method which is called router on a stick. This method uses a dedicated router for inter-VLAN routing, and this router should be connected to switch with the help of trunk link, either ISL or .1Q. We'll use today .1Q trunk link. Let's look at this topology. You can see here we have four hosts, one switch and one router. So two hosts will be in, let's say, VLAN 10. You can see them marked with the blue color, and two hosts will be in VLAN 20. They are marked with yellow color. We will configure VLANs on the switch, and we'll put corresponding interfaces in the corresponding VLANs. And then we'll move to the router and configure sub-interfaces for different VLANs, VLAN 10 and 20, and we'll configure the corresponding IP addresses. For VLAN 10, we use subnet 10.10.10.0/24, and for VLAN 20, we use subnet 20.20.20.0/24. And the corresponding IP addresses you can see on the screen. This is 10, 10, 10, 10, and 11 for VLAN 10 hosts, and 20 and 21 for VLAN 20 hosts. Let's start from switch. Let's create VLANs. Show VLAN brief. Let's see that these VLANs are already created. We have VLAN 10 and 20. Now let's put the corresponding interfaces to the VLANs. Let's do this with the command range. So we put fast Ethernet 0/1 and 2 into VLAN 10. So let's put in mode access, and access VLAN will be 10, and interface 3 and 4 will be in VLAN 20. Okay, now we see that the interfaces are correctly configured in the corresponding VLAN. So, faster than 0/1 and 2 are in VLAN 10, and 3 and 4 are in VLAN 20. Now let's configure a trunk interface to which the router is connected. So we put this interface. This is gigabit 1/1 into mode trunk, so it will be statically configured for trunk. As we have created VLANs and configured interfaces to this VLAN, now we can see that in the VLANs, hosts can communicate with each other. For example, first host can ping the second host in the same VLAN, and host which is in VLAN 20 can ping the second host in the same VLAN. But also now we can see that inter-VLAN routing does not work yet because we did not configure sub-interfaces on router. Okay, after creating these sub-interfaces and configuring IP addresses, we'll have connectivity between VLANs as well. Okay, let's move to the router. First of all, we have to switch on the interface, the physical interface because if physical interface is down, the sub-interfaces also will be down. So we have to shut this interface, and then we can create sub-interfaces. We can use the numbers for sub-interfaces not corresponding to VLAN numbers, but it is very good practice to use the same number because in future the troubleshooting process will be easier, and also you will always know which sub-interface serves which VLAN. So let's create two sub-interfaces, 10 and 20, and configure them for the corresponding VLANs. Interface gigabit slash 0 slash 0.10. This command will create sub-interface 10. And before we configure IP address, we have to indicate the trunking protocol and the VLAN number. So it will be encapsulation .1q, we'll use .1q protocol, and the VLAN number is 10. After this we can add the IP address, and that's it. Let's create second sub-interface. And now let's see if these subnets are added to the routing table. We can see that we have two directly connected networks. This is 10, 10, 10, 10, and 20, 20, 20, 20, and they correspond to the sub-interfaces we created. So now I think everything is fine, and we can check if the inter-VLAN routing is working. So let's repeat our ping command from the host in VLAN 20 to host in VLAN 10 and see if we have communication between them. So okay, we see now that the ping is okay, and we have communication between hosts. It means that our router on a stick method for inter-VLAN routing works. That's it for today, and in the next section we'll consider inter-VLAN routing using layer 3 switches and SVI interfaces.